Okay? So if we know the position function of a particle, we can find the full velocity. But now the question is, if we know the velocity, can we find a position of the equation, right? So now in this session, we are trying to find a function f we try to find a function capital F of x if f of x here is the velocity, then capital F of x here would be the position, right? Whose derivative is already known. It means f of x is given, small f of x is given. So the function f, capital F of x will be called an antiderivative of f of x. Okay. A function definition, a function f is called an antiderivative of the function f, small f of x, on the interval I if f prime of x derivative gives us f of x for all x in I. Okay? Just definition, right? And we have another theorem. If f, capital F, is an antiderivative of f on an interval I, then the most general antiderivative of f on I is f x plus a constant here, where c is a constant. because the derivative of a constant gives us 0, right? Therefore, derivative of it is clear that derivative of f of x here plus c will be derivative of f of x plus derivative of c, which is derivative of f of x, right? Where c is a constant. So we call it the general antiderivative of a function f. Okay. Now let us try to do some simple example. Okay. Find the most general antiderivative of first f of x, which is given is x squared minus 3x plus 1. So what is the antiderivative of f of x here? So before solving it, we see that the degree of this, the first term is x squared, right? So can you guess which formula we should use in order to find the antiderivative of this?
So we're just going to do the opposite of...
Again, please.
Are we just going to do like the opposite of x to the n minus 1? So it would be like...
Perfect, yeah.
1/3 x.
Thank you, Morgan. So we know that x to the n derivative, right? It will be n times x to the n minus 1. And if here n minus 1 is 2, right? Then x to the n should be x cubed. Very good, right? But remember, when we take derivative of x cubed, it will give us a number 3 in front of that. So in order to eliminate that constant, we need to divide it by 3 here. We do the reverse one. Very good. Thank you, Morgan. Here. So Gary, can you guess what would be the antiderivative of 3x here? Louder, please. 1/3? No, because you see, when we 1/3, you mean like this? Then you take derivative, it gives us 0, right? The second term. Here. So if 1/3x, let us try. 1/3x derivative give us 1/3. It's not enough, right? So remember, look at this. The antiderivative is 1 order higher than the derivative, right? If here is n minus 1, the antiderivative will be the order of n. Here, look at this. The order of this guy is x to the 1, right? So the antiderivative of this will be 1 degree higher. It means it should be something multiplied with x squared, right? But in front of that, there's a number 3. Remember, just leave it here, right? Then we need to divide it by a constant, which is the degree of this guy, which is 2. Double check it. Let us double check it. Okay? Means now if we take the derivative of 3 over 2x squared derivative, the constant, we can take it out of the derivative. It is 3 over 2 and derivative of x squared, right? So, which means it will be 3 over 2 times, what is it, Gary? 2 and multiply? Yes, x. Now, we can simplify it here. There's a number 2 here, and number 2, they cancel each other because this is multiplication. Therefore, it gives us 3x. Yes, and it is correct. It is what we have here, right? Therefore, the antiderivative of this will be 3 over 2 multiply x squared. But remember, in front of that was a negative sign. So keep it in mind and write it here, okay? Jack, is that okay? Yes, very good. And about the number 1 here, what is the antiderivative of this? Perfect. Yes. Or you can imagine this is x to the 0, right? X to the 0 is 1. You can imagine this way. Then antiderivative, or just, I don't want to confuse you more. Okay, you got it already. It is x, right? But this is not the most general antiderivative. What we need to do is to add a constant c, right? Okay. The whole things here will be the most general antiderivative of the function small f of x here. Okay. Now, when you go home, review all the derivative formula and train your mind to how to find the antiderivative of any given function. But before going home, let us do one more problem, okay? Let us try. So if f of x here is e squared, what is antiderivative of it? Perfect. E squared and plus c. Thank you, Carson. Great job. Right? So we see that e squared is simply a number. Since e is 2.7 something, it's simply a number. Don't be scared. And where c is a constant, very good. Let us try one more. If you practice well the derivative, you can find the antiderivative faster. Okay, if we are given g of t, which is 1 plus t squared divided by square root of t. And we find the antiderivative of this. Let us call it capital TG. Okay? This is what we need to do, right? Observation. Here, this guy is a quotient. It's really hard to find, right? Let us break it into small pieces. Okay? It will be easier to find the antiderivative. So now, yeah, let's go home and think about it. Tomorrow we will keep doing it. And see you tomorrow. Remember to do the review test, okay? See you all.